Okay, so good afternoon. Thanks, Inanna, for the invitation, to the panelists and I am one of the last obstacles to the end of the day. The title of my presentation is Designing Emergent Material Cultures, and I think in perspective to what you have seen today is the more practical, let's say, approach, as I will tell what we are doing in our lab in Politecnico with the perspective of Leonardo, and I think also of some approaches you have seen today. So the main statement, the starting point, is the environmental changes we are facing today. So the climate change, the biodiversity challenge, scarcity of resources, the urban thirst in cities. So what are we facing today, and what contribution we can give through the design and the material culture and the materiality. I will start with the metaphor, that is a quite famous one probably. It's the fate of Glaucus from a video from the Metamorphosis. You may know it's a very famous one, but he was a fisherman and he was fishing, and while fishing he was throwing away the fishes in the grass, and he was at a certain point he noticed that the fishes were going back in the water. So he said, what's happening? Why these fish are going back in the water? And so he decided to eat the grass. And when he eat the grass, he became immortal. So he becomes one of the gods of the sea. So this metaphors is the metaphors of the change through nature. So Glaucus, he loses some things because he loses his story, he loses his human part, but he becomes immortal, and also he has the possibility to foresee the future. So he gains somehow a different perspective from his loss. So I think it's a nice metaphor to start with the idea that there's a balance, there's a sort of conservation of mass that is one of the main laws of our planet, but somehow there's a continuous transformation. That could be also the possibility that we lose something, that there's something we miss, but we change for a different and maybe a more possible entangled future. So the fisherman is like the initial state becomes the divine one, and it becomes a sort of a new equilibrium in the planet because it gets this transformation. And also when Dante speaks of Glauco, he says that this is for Federico. You cannot say it with words because it's so powerful, the transformation he has, that you are not able to say with the language. So from this first idea of changing continuously material that can give you a certain insight of what I will show you in the different experiments, is the idea that you can continuously change the materials, the shapes, the components. And this is even easier today thanks to the tools we have, the computational tool, the material tools, the science we are working with. So we can really transform matter. The first example is linked to nature, and it's a project we have done for an exhibition some time ago in Triennale, and works with microalgae. We were asked to work with biologists in that case. Most of these projects are multidisciplinary, so we always work with different engineers, architects, designers, biologists. In that case, they asked us to make an installation inside an exhibition space that could compensate CO2. And microalgae in this case are very famous because they compensate CO2 much more than a traditional superior plant, let's say. And microalgae, they can also work with wastewater. So they not only work with purified water, but so they can use a sort of waste as energy, as food, to become something else, to become biomass, to become a plastic, to become another material. So this is in line with this idea of continuous transformation that can take from a waste or from something existing and modify and become something even better. This was the installation, and the idea was to make a component. What we do, we usually work at this meta level, so that's why we used to call metamorphosis meta components, because it's not a complete and closed system, but usually it's an exhibitor, a prototype that can show some possibilities. In that case, it was a filter between two spaces with a triangular dimension that can convey the light in the tubes, and the tubes are bioreactors with different types of microalgae. This is not new, let's say, but the idea was to use it exactly as a space. So it's a filter, it's a wall, it's a partition, could be in this material in that case, but it could be also in other materials. So we tried to use nature and the microalgae to feed the space, and in the same time to compensate the CO2 of the exhibition. This was the result, so how it was working. So artificial and natural was blurring in a new type of habitat, and we used also the biomass at the end. In that case, the water was clean, and we made pasta with the microalgae, and we had it in the exhibition. So it was sort of trying to continue. It was a little bit fishy as a taste, but the idea was we used the water somehow to make some food that becomes part of the exhibition. Another topic on which another material we were working with in this case is cork, and we use it for sound. This is another drawing from Leonardo that once they said he was discovering the sound waves. So he was one of the first to understand how the waves works and how they react to the environment. That is a quite difficult equation to solve and quite difficult to simulate even today. In that case, we have worked with acoustic, and we are still working with acoustic as a performance, because you deal with acoustic usually when it's too late. When you have a problem, you call the acoustician and you try to solve it. So while our idea is why don't we design the materials, the semi-component, the systems, so that they react to the environment and they can eventually transform in time. This is called the wheel of acoustics, and this is all the complete different fields. So this is also very multidisciplinary, I think. So which are the fields you can work with sound, and we work maybe with speech and then with architecture and visual arts more than other disciplines, but it's another ground that puts together different disciplines and can be worked with. Here we have made some audio and visual mapping of some spaces in Politecnico to understand how the waves are working, and so you can see these drawings related to the first one you saw of Leonardo. So he was really understanding that the waves goes to the different materials and then it goes back. So it was really anticipating something that is not even now easy to do with different types of softwares. Then we have mapped the space, in this case in Politecnico, and then we have designed different components with cork that can be modular and assembled in relation to how the space are used. In that case, I think what was the main issue is that the computational tools allow us to see and design the invisible, the immaterial, while shaping the matter. So we used all the data we had to shape these different components that we showed now. So we have different sound waves, or we could put different void and closed in relation to the different components where we need more speech. And we can also change the component and transform them in time. In that case, we were using a natural material. It binds only with warm, so you don't need any glue, any other artificial element, so it can go back in nature. So this we are using as a philosophy for much of the components you would see in the materials. The idea that then it can go back in the flows and even become better of what was the beginning, the first use they had. These are other examples looking at how the space is used, and so we use different types of patterns. These are done with CNC machines, and so the students also are exposed to the idea that when they design, they have embedded the material properties and also the production properties. So you're not only designing on an abstract space, but you're really designing with matter. This is the third case, it's form finding, so it's the idea of topology optimization. I think it's similar to what Nicola was showing. And in this project, we have used the sand waste from a construction site to make a component with 3D printing, as also François was asking. In that case is a project in UAE, in the Emirates, and they asked us to make external louvers with the sand from the waste from the construction site and to 3D print it, so in relation to the different parts they would need. We started with the design of thinking what is the material culture of the Gulf countries or in the Middle East, so the desert and the porosity between the spaces. So we tried to match the two and seeing how this materiality could go inside our design project. Then we start to model with different physical materials and also with 3D printing, because the request was to use the production methods, so to use 3D printers. We made some examples. And then we made different trials on the materials, like alchemists, understanding which one could better express the project, but at the same time be compatible with the environment and lightweight, and also have a lower impact on carbon footprint and on the project in general. And at the end we used this PLA but with Dubai sand. So it was a mix of the two, so a lightweight component that could in any case be recycled and be completely changed in another occasion. This is the pellet, the small system that goes in the printer, so we show you the fabrication. So we made very lightweight structure, a small aluminium structure. This is constant, so we had the possibility to hang the different system, but while we could really play with the different waves, using a different percentage of sand, a different opening, depending if inside. These are the Concertina Pavilion for Expo 2020, where there will be prayer rooms, restrooms, meeting rooms. And so we made different hypotheses, trying to understand how we could really, in that case, to put the matter as exactly where it was needed, and trying so to put together the form and the structural parameters of this external shading that you can just hang one on the top of the other. This is the panel subdivision. This is the printer. So it's quite a big one because it's 1 meter by 1 by 1. So the idea was to make the real component a scale that can be used in the building. And this is the final effect. So where you can really see the difference in the different panels. And the idea of Expo is while they do the building side, they take the sand, they put it in the printer together with this biomaterial, and they make the component on site. And then when the Expo is finished, it can be melted again and become another component or something else together. This is the example of where it will be, and these are some examples of how was the result. Trying to figure out this, also this image of the sand and to make it more material as possible. So in that case, it was a sort of customization and production of a metamaterial and metamatter, because the first part was really with the chemistry to understand the structure of the material, how much sand we could put in the PLA, because this was changing. If we had put too much sand, it would become rigid but fragile. If putting a very small part of sand, it will not have the benefit we were wishing, and also it will not have impact in the idea of using the sand from the building site. So it was always a sort of balance, let's say, from this idea of material balance of different factors that are not only material. It's also a fact of the context, of the approach, of how you perceive this material. So it's physical, physiologic, and semantic at the same time. This one is another project related with knitting. So I was putting the hand by Leonardo that used tissue. And knitting is a very old technique, so it's nothing new, let's say, but we have made this project, I think, last year with the idea of why don't we use knitting as a construction technique, because today we can really simulate how knitting is working. That is really not easy, because in the past you used to have a material, and then on the other hand you had the machine, but you really didn't know how this material could become an artifact, for example, a part of a tissue or something else. So we said, let's try to improve the properties of the design using the knitting technique, that is a quite ancient one, where you can really design and compute every node, every garment. And so we can really compute every yarn. On the yarn side, we said this is one of the yarn we use, a tissue. We use completely textile from post-consumer bottles from the Lombardy region. So we took the bottles from the Lombardy region, we were helped with the manufacturers who make us the yarn, and from the yarn we made our own knitting. So we made a sort of demonstrator in that case that would make visible and understandable this idea of computing matter. So we made the wooden structure and then the textile outside, quite simple one. But also we try always to link together with the performance. So what are we trying to reach? And we find out that we could at least find 4 different performance to give to this sort of a meta component that is not even only a material but is not a complete system. So we always work on the boundaries between a closed system and the material. So we said it could be visual, like putting lights inside and be a translucent knitted textiles, or it could be structural. So if you increase the type of yarns and you put, for example, metal yarns, it can be used also for existing buildings where, for example, you have a particular shape and you need to enhance the building. Or it could be acoustics, that is another one that is working quite well, because as you design it, you can understand how the wave is moving and how this textile can absorb different sound waves. And then we also made an HVAC system, so you have the air inside, instead of having the classical one, here we don't have that, you have inside a filter, so the air is much more diffused. With the aim to think of a component that can have also different performance, but that you can decide previously how you can design them and how you can compute them. And these are some examples. This one was the knitted one, and then we had the acoustic one. So we really was designing, trying to push the materiality. So how can we enhance the fact that we can really knit the surface, and giving a performance to this knitted surface. So it's a sort of meta component that reacts to the environment. So then I thought, as the seminar is imagining futures, I say let's go through the 3 figures, let's say, or the 3 steps we can, and I think today there was a lot of them. So the first one is, how will we be designing in the future? What the designer is doing, and how can a material culture or different material culture come from this new responsibility we have on the environmental part? On designing, I think we should go for a sort of non-designing way, because designing is a sort of poiesis, progetto or design in Italian comes from poiesis, and poiesis means that you have a very linear approach where there's a lot of things that are ways that remains apart. So maybe this idea of a cyclical way of designing, they call it circular economy, that in design is a little bit different, but why don't we try to design thinking of what the waste will be? Because now there's a lot of accent of using waste. But if you're using waste, that means you had waste somehow. So we should think of designing thinking where it will go. It could be a waste, because I think it's also difficult to think of doing something without any remaining part. But to think of where it's going, how it will impact in the environment, could be a different approach for the designer. The second one is to be a sustainable bricoleur, also, as Federico always says. It's a famous anthropologist, but the idea is to use the material and the resources as we were in danger, because probably we are in danger now. It's a technique that is different probably than to a very linear and scientific approach. It's more the idea to be activist in a pre-political way. So through the material you can embed the idea that you're trying to use the resources, to optimize the resources, because you can see exactly the structure of the material and you can embed them in the design, giving a meaning to what you're doing. So it's even pre-political as an activity of a designer. So it's not only something that needs, you can even move, let's say, a sort of nudge theory. You can move with very small steps in the way you design with the materials. And then this material culture, what type of material culture is arising from this approach? I think it could be another important aspect to see, a sort of continuous metamorphosis of the materials that maybe becomes also something that doesn't go in architectures. Some panels in the construction, then when they are dismissed, they go in the roads, for example, to be safe when they make streets. And then it can become something else. So this idea that is a continuously unexpected balance, a continuous metamorphosis that can foster this idea of a metamaterial culture that is in the middle between only an object or something very defined, but can continuously have a sort of space where it can change and become something else. And then I took this as an example of this Leonardo's continuously changing of things, of materials and variation, from a man to the old man, the young man, but then there's some writings that I read, is some legal stuff, and then there's a sort of machine coming on that. So this idea that there's a very overlapping of the different aspects, even in whatever discipline, but in designing with materials too. So there's a part that is what is the aim, what is the context, and why your project is done, but at the same time there's a lot of transformation on it. And this I took it to the Tate yesterday, but I think it was quite interesting. It was from Pike, and he said, my experiments are not always interesting, but not always uninteresting like nature. That is beautiful, not because it changes beautifully, but simply because it changes. So thank you.